Very good. So it appears that the denominator changes into what?
X minus 2.
Perfect. So from the very beginning, even if we don't have anything, we got, when we plugged in 2, we got 0 over 0. What do you think, what factor creates 0 over 0? Which we couldn't see that from the beginning. But what factor creates 0 over 0? If we plug in x equals 2 and we get 0 over 0, what factor we expect to clear?
X minus 2.
That's it. And here it is, as expected. So then what is the limit?
-2.
So when x approaches 2, 2 plus 2 is?
4.
The square root of 4 is?
2.
2 plus 2 is?
4.
With minus in front.
Professor?
Yes?
I kept refreshing to send in my thing, and I sent it at 6:30, but it kept not letting me send it. Like, I'm still stuck in the post reply.
Yeah, send it to me in an email, but I thought that we said 5 minutes extra. So what was the problem? What do you think?
I mentioned it. I texted in the chat, like, what was happening, but you're talking.
Yeah. So you needed more time than 6:25 to 6:30? Is that what you're saying?
No, it was like, as I was trying to turn it in, I think it locked. So it just kept me stuck, like, in what I responded. And, like, all I see is, like, the post reply. But when I click it, it doesn't let me turn it in.
Okay, because you exceeded the time. Is that what it is?
Mm-hmm.
Okay, so you can email it to me. Good. Other question, is this okay? This was 24. What else do we need to work on?
I have a question about that one.
Yes.
So when you plug in 2 for x and you get the square root of 4, could that not be plus or minus?
Okay, let's talk about that. This is very important. So the square root of 4 is only 2. When we solve the equation x squared minus 4 equals 0, and we move 4 to the other side, and we take square roots, the left-hand side is the absolute value of x, the right-hand side is only 2. Normally, we skip this step, and students get confused because skipping this step, if it was never explained to you, of course it doesn't make any sense. But we skip this step and we write x equals plus or minus 2, but plus or minus come from the absolute value, because we know that the absolute value is x or negative x for different values of x. And this equation is quadratic, which means we'll have 2 solutions. But the square root of 4 is only 2, always and forever. The confusion comes from the fact that we skip this step, and now all the students say, oh, the square root of 4 must be plus or minus 2. No. The plus or minus come from the absolute value of x, because the square root of x squared is the absolute value of x, is not x. The square root of x squared is the absolute value of x. So if this step was never explained to you, of course it will always be confusing. So when we come back here, the square root of 2 plus 2 is the square root of 4. The square root of 4 is only 2. 2 plus 2 is 4. With the minus in front is negative 4. Very good question. As I mentioned, you will learn here your algebra that was never explained to you or you forgot, the pre-calculus and calculus. Anything else? Other questions for me on anything? Okay, so are you saying that we can move on? Okay then, so let's move on. Okay. Again, sorry for the noise in the background. I think I am on page 4. Okay. So there was something about 26. Somebody said also, Austin, did you say something about 26, or is 26 okay, or something else? Was there something else?
That was me, but I think I can take it from here. Thank you.
So the 26. So remember 26, we did that in class. It's 2 plus age plus 1/2, right? So that's a rational function. So any number raised to a negative power is 1/a to the n, assuming that a is not 0, of course. So our next step is something called the precise definition of the limit. It's the only proof that is required in this class. So 2.4, the precise definition of the limit. We also like a shortcut of all this. We like to write the epsilon delta. Once we say the precise definition of the limit or the epsilon delta definition of the limit is the same thing. So this is epsilon delta. So these are Greek letters, and we use them in this definition. So the idea behind it I will explain in a minute, but I'm going to use some mathematical symbols. This is an A upside down for every, or each, or any. Instead of writing this, we just write this symbol. This, E backwards, there exists. I will find, where there is. This one, such that. And I'm going to add one more here. In belongs to. So you can see what's all this. Okay, in a minute I will explain why we're going to use this. You don't have to. You can say I'm not interested in these symbols. I'm going to write the words. So you don't have to use those. Then you have to write way more. But if you want to use these symbols, then they will become much shorter. So for every, or for each, or for any, there exists such that, and belongs to, or in, or belongs to. Okay. So what is the precise definition of the limit? I'm going to make it very simple. We're only going to look at linear functions. Linear functions only. No quadratic, no cubic, nothing, just the simplest possible example. But first I need to explain the definition. So let's start by saying the following. Let's look at an example. So here is a function. I'm going to use numbers first just to make sure that it's clear and easier to understand. I'm going to say that this is 5, and I'm going to say that this is 6. And here's the first question. Limit as x approaches 5 from f of x. Can anyone give us the answer? I need to plug in my device. 1 second, 1 second, 1 second. Okay, I'm back. So can anyone give us the answer here?
6.
Of course. Yeah, it's a simple situation. Perfect. As x approaches 5 from either side, of course, as you see, function values get closer and closer, closer and closer to 6. This is equivalent to. This is the double equivalency symbol. Double equivalency. What does this mean? This implies what I'm going to write. What I'm going to write implies this. So it goes both ways. Of course, I have no room here, so I'm going to move on to the next page. I'm going to write it again. So limit of f of x as x approaches 5 from either side equals 6. This is what I'm going to write here implies this. This implies what I'm going to write here. That's the double equivalency. It goes both ways. A implies B, B implies A. Okay. So I'm going to write it with the symbols, and then I'm going to explain each and every step. For every epsilon positive, there exists a delta positive such that 0 less than the absolute value of x minus 5 less than delta implies that the absolute value of f of x minus 6 is less than epsilon. Yes, I know it means nothing to you, and I don't expect it to mean anything yet. After we decipher all this, it will be very easy. But right now, it sounds and looks very complicated. Okay, so step by step. The limit of f of x as x approaches 5 is 6. What does this mean? It means this. I'm going to copy that graph. I don't want to go back there. I'm going to take this away. So if I create an interval around the limit, this is the limit. This is the y, right? So if I create an interval, symmetric interval around the limit, small. In other words, this piece here has 6 plus a little bit epsilon, a little bit. Of course, can anyone give us this number here? If this one is 6 right here in the middle, and this one is 6 plus epsilon, what could this one be at the bottom?
6 minus epsilon.
Of course. Excellent. Thank you. So if I create an epsilon, if I determine an epsilon, a tiny number, but positive, for every big, small as you want, for every epsilon positive, so we deciphered this and this and this so far. Next, I will find there exists, for every epsilon, I will find a delta. What does this mean? Okay. Horizontally, I go with this number till I meet the function. Horizontally, I go with this number till I meet the function. And then come down to the x values. Come down to the x values. So it happens that in my graph, it appears that both sides are equal. But normally they're not. And they will not be equal. So this piece is a value. This piece is another value. Well, which one is delta? Delta also has to be positive, and it has to be close to 5. Yeah, it's close to 5. But which one is delta? Is it delta 1 or delta 2? I have to choose the smallest. I will explain why to choose the smallest in a minute. I have to choose the smallest of these two, either delta 1 or delta 2, just one. I can only determine and have one delta corresponding to this epsilon. It has to be positive. So for every epsilon positive, I will find the corresponding delta also positive. We deciphered this so far. Such as what? By definition, x minus 5 is the distance between x that I pick and 5. So let's say I pick x here. You can say pick x here or pick x here. It doesn't matter. Such that the distance between x and 5 is smaller than delta. I cannot pick x here because the distance will be bigger than delta. So I pick this x value so that the distance between x and 5 is smaller than delta. If this is delta, this is the distance between x and 5. So for every epsilon greater than 0, I will find the corresponding delta greater than 0, such that the distance between this x and 5, this means not equal to 0. So you can say, wait a minute, why are you writing this? Because the absolute value is always positive. Yes, but I'm writing it because it's missing the equal symbol. So I cannot pick x to be 5. That's all it means. So the distance between x and 5 is less than delta. This will imply, here it is, that for this x, the distance between 6 and f of x, f of x, the distance between f of x and 6 must be smaller than epsilon. And it is. See, if I pick here, first of all, I can't because the distance is smaller than bigger than delta. And also, f of x will not fall within epsilon away from 6.
What's epsilon again?
Any value positive around the limit. So epsilon is something that we pick. So for every epsilon, I will be able to determine delta such that when I pick x, f of x will be within the distance between f of x and 6 will be smaller than epsilon. Why all this? It's because the limit exists. If the limit doesn't exist, you cannot determine this. Here's a counterexample. You could say, look at this. I can choose this epsilon, and then I will find a delta. It's either this or this, and I will choose the smaller of the two. So the limit exists. No, because the symbol says this, for every, for each, any. This system worked only for a particular epsilon. But look here, if I want this epsilon, I will never be able to find a delta because the limit doesn't exist. But here, this is valid and true for any epsilon, tiny or big, whatever you want. It does work because the limit exists. Here, it does not. It works for this one. It works for this one. It works for this one, but it doesn't work for every. I cannot determine delta because the limit doesn't exist. So let me illustrate, and we'll go back if we need to explain again. Let me illustrate with an example.